Hi learners, I'm Smiu Zablon teaching chemistry. Today we are going to go through chemistry about the periodic table, and I think you are going to enjoy my lesson. Welcome. In the periodic table, we have said that we have periods and groups. Those elements have been arranged in rows and columns. When you move down in the periodic table, that is in rows, that is periods, and then we have columns, that is the groups. Moving down the group, down in the periodic table, you find that those elements have been arranged. In periods, we have said that we arrange those elements in period because of the energy levels. Those elements that have been arranged in energy levels and in groups. So we have a 118 elements, but in our level, we are also only going to look at only 20 elements. Those 20 elements, they have been arranged in a way that, number one, concerning to the, or depending on the periods or energy levels that they have. Energy levels that they have. In groups, they have been arranged in groups because of the outermost energy level electrons. How many electrons are in the outermost energy level? So for example, when we have those elements that ending in the electron configuration with 1 electrons, those electrons are found in group 1. When you find that those elements having electron configuration with 1 energy level, those are found in period 1. So we are going to arrange those elements in the periods. I may take an example of any element. For example, I might take magnesium. Magnesium have an atomic number of 12. When we write the electron configuration of magnesium, we have 2:8:2. We have said that the first orbital or the first energy level should be occupied by a maximum of 2 electrons. The second energy level should be occupied by a maximum of 8 electrons, while the third and the fourth energy level should be occupied also by a maximum of 8 electrons. So we will find that magnesium, we can predict the group and the period at which magnesium is going to appear. For example, we have said that periods, we determine an element by periods in terms of energy levels. For example, how many energy levels are in magnesium? 1, 2, 3. 3 energy levels. So we can say that magnesium is found in period 3. And we have said that when we present a period, we present a period in any way. For example, you can give out a number, the name of that number, or you can give out in Romans also. Also, we can say that we have said that we can predict the group at which this element is going to appear. For example, we have said that when we determine a group, we look at the outermost energy level. How many electrons are there? We have said that here it's 2 electrons. So we find that magnesium will found in group 2, and we have said that groups, we only assign groups using the Romans. So make sure that when you assign a group, you write in Romans. So you will be given an element, and then you will be given a question to place that element in period and in groups. So make sure that you are able to be equipped to answer that question very well. Let's try another element. For example, we have potassium. Symbol of potassium is K, that is kalium. So potassium has atomic number of 19. Let's give out the electron configuration. 2:8:8:1. Yes. So you will find that when you count the number of energy levels, 1, 2, 3, 4. So we say that potassium will be found in group in period 4. We have said that period you can present it using numbers or any. And which group, you look at the outermost energy level. How many electrons are there? So we find that it is 1 electron. So it's found in group 1, Roman 1, group 1. So you can be able to assign those elements according to the groups and the period, as long as you have been given the atomic number. Number 2, you have been given the electron configuration of the element. let's look at how those elements have been arranged in the periodic table. We have said that when you move down, that is in columns, you will find that you will find elements being arranged there. When you move across the period in rows, these are lines running from east to west or right to the left. Right to the left, and you will find that we have in the periodic table, we have in our normal periodic table, we are going to only to study 8 groups. You will find that 10 groups that are transition elements. We are going to mention them, transition elements. So when we count 1, 2, 3, 4, 5, 6, 7, there is group 7, and then we have group 8 elements. So you will find that those lines moving from west to east or right to the left, those are groups. Groups are running from east to west or right to the left. And then we have periods. These are lines moving. So these elements have been run from east to west. Those are periods. So we find that when we have groups, group 1, group 2, in Romans, group 3, we have said that the groups are being assigned in Romans. Group 4, group 5, group 6. So we have said that groups have been arranged from as they move down from up, bottom, top, bottom. So we find that this group 1, group 2, group 3, group 4, group 5, group 6, group 7, group 8. So we normally have 8 groups when we arrange those 20 elements. And then we have said that these elements that are found here, these are transition elements. So we shall also look at the characteristics of transition elements. We have groups, we have periods. Periods, we have said that those are lines running from east to west or right to left. We have period 1, period 2, period 3, period 4. We have 7 periods, but in our level we shall also only deal at 4 periods. So when we arrange these elements across the period or down the group, we will find that we accumulate to up to 20 elements. Number 1, let's assign the names. We have said that we have the chemical families. Those elements have been arranged there in terms of chemical families. Chemical families arranged elements with the similar characteristics or similar chemical properties and physical properties. Those elements having the same physical properties, same physical, chemical or chemical characteristics, they are being assigned in the same chemical families. We have in our normal periodic table, we have 4 chemical families. Chemical family number 1, we have alkali metals. We have alkali metals. We have said that they are metals. We shall look at how those metals have been assigned. We also have alkaline earth metals. Alkaline earth metals. We have halogens. And then number 4, we have noble gases. So, but in our absence, we also look at the metalloids. Metalloids. We shall also look at the metalloids. So we have said that those elements have been arranged in groups and a periodic table, and also they have been grouped into chemical families. Chemical families, we have said that these elements have similar chemical characteristics, chemical properties. You will find that in physical properties you might see it has some similarity. Also in chemical when they react, also they have some similar chemical properties. So number 1, we shall start by assigning those groups the chemical families. We have said that alkali metals, these are group 1 elements. So this group 1, as you move down the group, these are alkali metals. We have also said that alkaline earth metals are group 2 elements. When you move down the group, these group 2 elements, we just skip group 3. We just found group 4. Group 4, these are called metalloids. They either gain or lose electron. They either gain 4 electrons or lose 4 electrons. But normally in these metals they will gain 4 electrons. We also have halogens. Halogens, these are nonmetals, superior nonmetals. We will find that they gain one electron. They gain one electron to become stable, halogens. And we have said that the halogen means salt. Noble gases normally group 8 elements, And number 2, they are very, very stable. We shall look at the characteristics of each and every chemical family. Let's look at let's look at alkaline earth metals. Let's look at the alkaline earth metals. We have seen that these elements, why are they being assigned a chemical family known as alkaline earth metals? Number 1, why alkaline? Alkaline because when they form oxide, that oxide dissolves in water, it forms a basic solution. Alkaline, we have said that alkaline, when it forms oxide, that oxide dissolves in water, it forms a basic solution. Number 2, why earth? What is the word earth? We have said that earth, initially we said that earth because that oxide, it is slightly soluble in water. So slightly soluble in water. So when somebody asks you why alkaline earth metal? Alkaline earth metal because when they form oxide, their oxide when dissolves in water, it forms a basic solution. And we have said that basic solution automatically will turn red litmus paper to blue. We have also said that why earth because that oxide is slightly soluble in water. So when being asked why alkaline earth metals, they are oxides when dissolved in water, it forms a basic solution. Number 2, why earth? Because their oxide is slightly soluble in water. Let's look at the group 2 elements. We have said that alkaline earth metals are group 2 elements. Number 1, they are group 2. They are group 2 elements. Number 2, they lose 2 electrons to become stable. They lose 2 electrons to become stable. Number 3, they dissolve in water. That is their oxide dissolves in water. The oxide dissolves in water to form a basic solution. So these are small characteristics or the physical characteristics of alkaline earth metals. They are group 2 elements. Number 2, they lose 2 electrons to become stable. They dissolve to form a basic solution. So you will find that these metals have a specific or similar characteristics. For example, all of them lose 2 electrons to become stable. Number 2, all of them, when they form an oxide, they dissolve in water, and we have said slightly because they are earth, slightly dissolves in water to form a basic solution. And you will find that these metals, when we are looking at alkaline earth metals, these metals are less reactive than alkali metals. So let's look at the physical characteristics of these alkaline earth metals. For example, let's give out the number 1. We have beryllium. Beryllium has atomic number of 4. Electron configuration is 2:2. We have magnesium. Following magnesium, it has atomic number of 12. Electron configuration is 2:8:2. We also have calcium. Calcium, atomic number 20, 2 is to 8 is to 8 is to 2. You will find that these alkaline earth metals have a specific or similar characteristics. All of them, the outermost energy level ends with 2. So it loses 2 electron, 2 electron, 2 electron. So we may introduce, we also say that it has a valency. The valency is the electron lost or gained in an element or in an atom. We have said that beryllium will lose 2 electrons. Magnesium will lose 2 electrons. Calcium will lose 2 electrons to become stable. So let's look at how this element forms an ion. They forms an ion by losing 2 electrons. For example, beryllium will lose 2 electrons. When it loses 2 electrons, it obtains a positive charge which is divalent. They form a divalent cation. We have said that cation is a positively charged ion. Cations are positively charged ion. So when it loses 2 electrons, it forms divalent cations. So you might be asked to give out an element that forms a cation, which is a divalent. You just choose in the group 2, which is alkaline earth metals. We also have magnesium. Magnesium forms an ion by losing 2 electrons. That is forming an ion. Calcium also loses 2 electrons. So you may find that similar characteristics is following according to the valency. Also the oxidation number of this element, it is positive 2. Oxidation number, we say that when we assign a oxidation state, we give a plus or a charge and then a number. We also have plus 2. So this is the elements according to the groups, the top up to the bottom. We have beryllium, magnesium, calcium, atomic number, electron configuration, the charged ion. Then we have the oxidation number. And we have said that when we conclude in alkaline earth metals, say that these elements forms a divalent cation by losing 2 electrons. Those 2 electrons lost, that is the cation first. Positive, that is cation charge, while 2 is a divalent. So let's look at the physical characteristics of this element. Physical characteristics is what you see, what you touch, and how do you feel those elements. You will find that when you have beryllium, you have magnesium, then you have calcium. You will find that beryllium is somehow hard, magnesium is soft, and calcium is powder form. We will look at why this trend is behaving like this. Why this is hard, this moderately less hard, and this one is powder form. We have said that the alkaline earth metals, they are very, very soft, which can be cut by using a knife or a hand. For example, they can be hammered into sheets. They are malleable. Ability of a metal to be hammered into sheets. Malleability. They are very, very brittle. They can, like beryllium is very, very brittle. We have said also that when this beryllium, magnesium, and calcium dissolves in water, it forms dissolves in water, forms a basic solution, that turns or changes red litmus paper to blue. It has an effect on litmus paper. Number 3, we find that this calcium, when this calcium can react with oxygen. Calcium can react with oxygen. So when you are being asked about the beryllium, magnesium, so physical, we find low melting point and melting point. Physical characteristics about melting, how soft they are. We shall look at why are they soft. Let's